My dear students, in this video now we are going to learn about the preparation and properties of the benzimidazole. Benzimidazole structure is like that. It is a fused aromatic compound. It is a fused compound of the benzene and imidazole. So that's why we call it as the benzimidazole. First of all, we discuss about the synthesis of the benzimidazole. Here, as the first method, we use the orthophenylene diamine. Look here, if we remember the ethylene diamine, we can easily remember the orthophenylene diamine. So look here, this is ethylene diamine or 1,2 diaminoethane. In the similar manner, we can write the orthophenylene diamine. So look here, this is the benzene ring, and if you write the two NH2 groups on the adjacent positions, that becomes the orthophenylene diamine. If we heat this orthophenylene diamine with what is that, formic acid, look here, at about the 100 degrees centigrade, water goes outside and we get the benzimidazole. So look here, we can write NH2 here as NHH. So look here, NH and OH, and H2 and O goes outside in the form of two water molecules, and we get the benzimidazole. Now we discuss about the second preparation method, that is the from carboxylic acids. Here also we use the orthophenylene diamine. So look here, this is orthophenylene diamine. For convenience, we write NH2 group as NHH. So here also we write the same manner, in the same manner. And here we take the carboxylic acids or COOH. And here as the condensing agent or as the dehydrating agent, we use the polyphosphoric acid. Taken in. So this is PPA. PPA means polyphosphoric acid, and here we get the imidazole, benzimidazole derivative. And here we have to write R. This R we have to write here. Now we go for the mechanism. First of all, this carboxylic acid gets the one proton from the phosphoric acid, polyphosphoric acid. This is from PPA. As a result, we get this carbocation. Okay, na? This carbocation then attacks on this one, orthophenylene diamine. Okay, now water goes outside like this. H2O, and we get positive charges here. Now it loses one proton. As a result, we get the benzimidazole. We go for the third preparation method, that is by using the 1,5 diphenyl tetrazole. The structure of the tetrazole is like this. So this is tetrazole, and at the first position and at the fifth position we have write the phenyl groups. So this is 1,5 diphenyl tetrazole. Okay, in the presence of the light, it undergoes the photolysis. And it loses the nitrogen molecule. As a result, Look here, we can write this phenyl group in the form of the benzene ring like this. And in between this carbon and this nitrogen, a double bond will be formed, no? So here we have to write a double bond. Okay, and look here, on this nitrogen, what is that, two lone electron pairs will be present like this. So, and here we have to write one phenyl group like this. This one undergoes cyclization and we get the 2-phenyl benzimidazole. So this is 2-phenyl benzimidazole. 2-phenyl benzimidazole. So 1,5 diphenyl tetrazole, 1,5 diphenyl tetrazole undergoes photolysis and converts into the 2-phenyl benzimidazole. We go for the fourth preparation method, that is by using the aryl amidins. So in a amidin, we have the CNH and C double bond NH bond. So this is known as the amidin structure, and here we have to take the N-phenyl and so this is N-phenyl, N-hydroxyl benzimidine. So this is known as the N-phenyl, N-hydroxyl amine. Sorry, N-hydroxy amidine. N-phenyl N-hydroxyl amidine. Okay, this on treatment with the benzene sulfonyl chloride, that is C6H5SO2Cl in the presence of a base. Generally here we use the triethylamine as a strong base, and in the presence of the strong base cyclization occurs and we get the 2-phenyl benzimidazole. So it is 2-phenyl benzimidazole. We can get the same compound in another way by treating the, what is that, N-phenyl benzimidine. This is simple N-phenyl benzimidine with sodium hypochlorite in the presence of base, that is the sodium hydroxide or potassium hydroxide. So here 2-phenyl benzimidazole is prepared either by using N-phenyl N-hydroxylamidine or simply N-phenyl amidine, N-phenyl amidine. We go for the chemical properties of the benzimidazole. In benzimidazole, electrophile will be substituted at the 5th position and nucleophile will be substituted on the 2nd position. And in some cases electrophiles are also substituted on the nitrogen atoms also. So first of all we go for the reactions in which electrophiles are substituted on the nitrogen atoms. So first one here, it is the methylation. So that means alkylation. Here when benzimidazoles are treated with the alkyl halides, we get the N-methyl benzimidazoles. And when this benzimidazole is treated with the formaldehyde in the presence of the secondary amine, we get a condensed product, and this reaction is known as the Manich reaction. Okay, so look here, one hydrogen from here and one hydrogen from here is abstracted, and we get this secondary amine. And when this is subject to the acetylation in the presence of pyridine, we get the N-acetyl benzimidazole. And when it is treated with the oxirane, we get the 1-hydroxyethyl N 1-hydroxyethyl benzimidazole. So this is hydroxyethyl, OCH2 CH2 group is known as the hydroxyethyl. Generally C2H5 is known as the ethyl, no? So in the place of one hydrogen of ethyl, hydroxy group is present. So that's why we call it as the 1-hydroxyethyl. 1-hydroxyethyl benzimidazole. Now here we observe some examples where what is that electrophiles are substituted on the fifth position. Here it is the nitration. For nitration, here we use the mixture of the concentrated sulfuric acid and concentrated nitric acid. So this is 5-nitro, sorry, N-methyl 5-nitro benzimidazole, and here it is the 1-methyl 5,7 dinitro benzimidazole. And in the similar way, in bromination also we get the two type of products, that is the N-methyl 5-bromo benzimidazole and N-methyl or 1-methyl 5,7 dibromo benzimidazole. Okay. So, but while giving the name, we have to follow the alphabetic order. So, I say the once again the name. So, look here, it is the 5,7 dibromo 1-methyl benzimidazole. Okay. In nucleophile substitution reactions. So, here when these benzimidazoles are treated with the alkyl lithium, what happens? Lithium will be substituted on the nitrogen, and when this 2-methyl benzimidazole is treated with the N-butyl lithium, lithium is substituted at the two positions, and the compound becomes as the 2-lithium-methyl 1-lithium-benzimidazole. So this hydrogen acts as the acidic hydrogen. So that's why in the presence of this base, hydrogen will be abstracted, and in the place of the hydrogen, lithium ion will be substituted. Okay. Now we go for the photochemical reactions exhibited by this benzimidazole. Benzimidazole on treatment with the UV radiation in 1% ethanol solution undergoes dimerization, and we get the two types of dimerized products here. Okay. Benzimidazole on oxidation with KMnO4 or K2CR2O7 or hydrogen peroxide gives us the imidazole. What is that? 4,5 dicarboxylic acid. Okay, na 4,5 dicarboxylic acid. And an oxidation with the lead dioxide gives us the 2,2 dash bis benzimidazole. And 2-methyl benzimidazole on oxidation with selenium dioxide in the presence of dioxane gives us the orthohydroxyacetonilide. This is the acetonilide and this is the hydroxy, so orthohydroxyacetonilide. Thank you for watching.